Hello, everybody. It is 1:31 p.m. Central Time on the 29th of November, 2020. It's Sunday here in the United States. Hope you are doing well. We are here to talk about seismic events. In case you don't know where you're at, and we're using the program Earthquake 3D, which there's a free version and a paid version. Either version will show you the quakes. We use the paid version to combine the feeds. I don't get anything for recommending it. I have to say that almost every time. There's always somebody who thinks I'm getting something from the program, but I use it myself and pay for it myself. Now we're looking at about 48 hours worth of earthquakes. And again, like I said, we're using two agencies, the USGS and EMSC. So we get a good idea of what struck in the last 2 days. And we're going to start right here in the middle of this whole outbreak of activity in the past 2 days. The pinkish-colored earthquakes are older, the whitish-colored earthquakes are younger, and this has all happened in roughly about 48 hours. So it's a lot of movement going on around the plate boundary. Now let me show you the plate boundary. Then what we're going to do, oh wait, USGS map, having some problems here. There we go. So looking around the plates, plural, we are over here in the West Pacific around Australia and India, the Indo-Australian plate. Earthquakes went all the way up around India, back down and across Indonesia, back down to Fiji, back through New Zealand, and back around south of Australia. In other words, this whole thing just shifted in the last 2 days. 3 days if you want to go back the full time that it started. It started with a bunch of deep earthquakes down below Indonesia, Fiji, and Japan. And those deep earthquakes resulted in shallower, larger earthquakes in the 5-ish range, 5.5 as high as 5.5, spreading out, again, all the way around this portion of the Pacific and Indo-Australian plate. Right in the middle of the whole thing, right here, a volcano that had not erupted since 2012 blew last night with a 50,000-foot high blast at Luotolo Volcano. And that might be Le-Watolo. I don't know how it's pronounced, not going to even bother to try to figure it out. It's a volcano that hasn't erupted in a very long time, and it went up to 50,000 feet. I put out a video on that last night, and I want to take you over to that video really quick. Big shout out to everybody who shared the info. But down below the video, we can click on this and go see videos of the blast here over on Twitter. Now look at that. Just look at it. That is just the most amazing looking blast. Straight up huge mushroom cloud. It went up into the stratosphere. And let's see if I can find, let's see if I can find other video of it here. It's the most impressive shot. Yeah, this right here. Look at this one. Oh, wait. So out in the ocean, people were out to sea and they captured it. And look at it breaking into the stratosphere up top. That's that 50,000 foot high level there where it reaches up and starts to flatten out. Almost like it's some giant cumulonimbus. But in this case, of course, it's made of all ash. Now, that's going to deform the volcano that was once somewhat symmetrical. I would think when this is all done, there's going to be a pretty big crater at the top of this volcano. Again, it has not erupted really big in a very long time. Really, you could go back to 1951 on the last huge blast, but 2012 there was a blast as well, so that was the last eruption of it in 2012. That all being said, a 50,000 foot high blast right in the middle at the spot where pretty much all these rings overlap on, right next to East Timor. Now since then, since the eruption, this is what's pretty much taken place. A spread of upper 4s, 4.6, 4.7, going across Java, Sumatra, really tailing off up here with another 4.7 on the plate boundary at the tip of Sumatra. Up here. So following the red line over to the west, a spread of activity. Same time that's taking place, new 5.0 level activity struck down on our fracture zone in the Indian Ocean. Look at this in the last 3 days. Man, you want to talk about a perfect spread in a parentheses shape, or a backwards letter C, going all the way up to the Gulf of Aden. Check the Gulf of Aden off the list, 4.5. Check Iran off the list. We issued a warning for Iran at the South Plate boundary, 5.0. We also have that 5 filling in the middle point between our two previous pink earthquakes. Look at the plate boundary this way. The stair-step fracture zone. So we have 5s going down and around and up all the way to Iran, back across India, back down and around into Indonesia. Or 4s and 5s. Now, we have to check off another location that was warned. Taiwan. Taiwan was struck by a 5.0, 4.9, directly on the shores of Taiwan. Now, that 4.9 marked in white, we actually have to go over to the east and zoom in to find our other 5. Here, let me turn down the rings a little bit. This right here, this 5 struck back on the 24th, 5 days ago. When that struck, I issued the warning for Taiwan for a similar sized earthquake to the 5.0 to be striking on the other side. Other side of what? The other side of the plate boundary. We got a 5 over here 5 days ago. And I said parallel over to the west, we would watch Taiwan. So check Taiwan off the list. It's an equal movement on both sides of the plate boundary. And it's going up towards Japan, and where it reaccumulates right here at Tokyo. Now, the pinkish-colored earthquakes all struck in the past couple days, so let's get those out of there again. And just look at what struck since yesterday, and you'll see it. The middle point was hit, but it's just a small little earthquake right here where the H-shaped bend in the plate boundary comes together. So, new small earthquake there. You know what? I mean, we could go look it up, but it's right out in the ocean. It's not much to see there. Just the plate boundary. So let's recap. A spread of earthquakes going all the way around the Indo-Australian plate took place over the past couple days. Now followed by a 50,000-foot high blast right in the middle. By the way, this was the warned area. We talked about Luotolo yesterday. We talked about the threat of big release here in the middle. And I said that volcano was a sign. Well, that volcano just blew. That is the big release. Now, is there going to be another big release, seismically speaking, now that the volcano is gone? Yes. Likely next to it, Bali, in the middle of this open area where there's no seismic activity, is likely going to break apart with a new earthquake at some point here really soon. But looking at it overall, I'm just going to tell everybody, we warned for it, now it's it. Now let's move on over because we have another place to check off on the list. This was open yesterday, a big open silent zone around New Caledonia. It's been filled in by a 5.5 earthquake. Let me show it to you on the plate boundary. Okay, right through here, you see it makes a U-shaped bend and goes down to the south, and the red line stops, but the plate boundary does not stop. They just don't have it marked there. So looking back at it this way, New Caledonia was checked off on the list last night, this morning, 5.5. Now 4.9 is right next to it. You're going to see a lot of these 4.9s, and 4.6 is right next to each other. Pretty weird that they're all 4.9, wouldn't you think? But anyway, let's go down to New Zealand. A 4.6 struck right next to the plate boundary on the north side of New Zealand, north of Wellington. And technically my warning was right here at the middle where the red line is going down to Kaikoura and up to Wellington. So just north of Wellington, there it is, 4.6. So check it off the list. Then, last night, yesterday, that 5.1 on our fracture zone here, well, that was followed by another 5 and a 5.1 here. So the spacing on that, though, to see it, it's amazing, right? It's a huge distance apart, but we're talking on the plate boundaries again. Let me show them to you this way on the USGS map. Plate boundary down south, plate boundary over east. The red lines, following it like a road. Now, when it follows it like a road, I've talked about this many times, energy travels across the fracture zones, coming from where our letter D is over on the western side, and going over to the east, following, again, the fracture zones, which you can see, hopefully, here on the screen if I keep it still for a second. Let the bit rate catch up with the graphics here. So, over to the east, a 5.8 to 5.9 earthquake, let's just call it a near 6, struck at the border of Argentina, Bolivia, and North Chile. Now, there was a deep earthquake here a few days back, and it was a deep 4-point-something. Prompting me to issue the warning for a shallower, larger earthquake to come in, and this is near 6.0, as we were expecting. An increase to go up to 6, but something weird happened here. First of all, let me click on the info from the Europeans, 5.8, and let's click on the info from the USGS, and it's 5.8. But something happened with another 5.9 earthquake that got downgraded to a 4.6, and I don't even see it here on the feed anymore. Very weird. Something weird was going on with these earthquakes last night down in South America. It was near 6.0. So the USGS finally came in with that 5.8, but so many people contacting me about them downgrading the 5.9 to a 4.6. And everybody's saying, how can they do that? And I go, well, I don't know. I don't know. Now look at the spacing on these fours going up across Central America. What you're going to see is a 4 here in South Peru, right next to Sabancaya volcano. Sabancaya volcano put off a 25,000 foot high blast a day ago, which we didn't even really hear much about. Now another 4.7 struck right at the border with Ecuador and North Peru. But the spacing on this is just perfect. Now right in the middle, in between the earthquakes coming out of Central America down at Panama and the 4.7 I just talked about down here at the Peru-Ecuador border, that middle point, Nevado del Ruiz volcano had just erupted just a few days back in the middle of Colombia. Now, I would like to go over and just check the volcanic ash advisory list, just see if anything else is on the list. So, multi-level eruption continues to go on. Flight level 100, or 100, which is 10,000 feet, up to 500, or 500, 50,000. That's Luatolo that we've been talking about over in Indonesia. Sabancaya, weak in intermittent emissions. Oh, man, that is so annoying. You know what? Again, people telling me to get ad blocker. I might. I try to show support to everybody who carries the earthquake info, so they get the ads and all that stuff. Yeah, look at that. Sorry, I didn't mean to move the microphone there. So we're going up to 18,000 feet with that. Okay. I just have to look at that. And now, the others on the list, for instance, Suwanee-Zajima and Popocatépetl, Dukono, Sanjay, those are all regular eruptors on the list. Kluchevskoye in Russia? Oh boy, okay, Mount Sinabung, a 10,000 foot high blast. That's over in Sumatra, Indonesia. Is there anybody else on the list? Mount Semeru, a 16,000 foot high blast over in Indonesia. Epico, up at the Kuril Islands. All right, that's a lot of eruptive activity to go from next to nothing over in Indonesia up to this. Let's just rewind again. I know we were just in South America, but I just got to bring this up. Indonesia had no eruptions. Well, one volcano erupting a few days ago. I want to say like 4 or 5 days ago was one erupting. Now we have a 50,000 foot high blast here at Luatolo. We have a 10,000 foot high blast at Dukono. We have a 16,000 foot high blast at Semeru. And we have a 10,000 foot high blast over here at Mount Sinabung. And do you think it's any coincidence? Right where all the rings overlap, that's where the blast is at Sinabung. This is the middle open area that's a fulcrum point waiting to get hit. That's where the 50K foot high blast just happened. Semeru from last night over to the west of it. That's all going on over in the West Pacific. Over here in the East Pacific, no eruptions across all of Chile. We have to go up here right into the middle of South America for Sabancaya and its 18,000 foot high blast. And a new earthquake right next to it. Up to the north, we have Sanjay and Reventador, both erupting here in Ecuador. That's 2 more, so that's now 3, going from central to the north. We skip over all of Central America and we get up to Popocatépetl, which is erupting in Mexico City, or right outside of. Fuego volcano has been erupting here in Guatemala. Let's add them together. 1, 2, 3, 4, 5 eruptions across Central and South America. Jumping over here, how many do we have over here? 1, 2, 3, 4, 5, going up to Japan. Suwanee-Zajima in Japan. We go in the North Pacific and we have 1. Kluchevskoye. 2. Kluchevskoye and Epico, both right next to each other there. So it's about equal on both sides, and then up to the north we have a spread going across that middle point that's filled in with a bigger earthquake there, up next to Kamchatka. So it all ties together, the volcanic activity, the deep earthquakes across Central America, South America, West Pacific, North Pacific. The Ring of Fire, if you want to call it that, is lit up right now with major activity. And to see that activity, I have to back it out. This is 48 hours worth of earthquakes. This right here is a lot. Now, number-wise, for the week, we're at 2,040 total reported earthquakes. We've seen that go up to 5,000 before. So the number of earthquakes overall on the planet for the last few days, for the last 7 days, is lower, half, than what we've seen at major outbreak times. So what's happened here in the past couple days, it's flared up. It's flared up big time in the past few days. We went from next to nothing up to this, and all the deep earthquakes are taking care of that. That's what's causing this activity to spread out across the planet. When you start seeing fives spread across the whole South Pacific, go around South America to the mid-Atlantic, fives spread out and over to the west, all the way over to Africa, you see fours spread up to the north with a 5 right in the middle of all of them. I haven't even talked about Asia and Europe yet. Let's get into it. Let's go over into Asia and Europe. So we're bouncing around the planet. South America just moved and shifted with its volcanic activity. Iran, check it off the list. We warned the plate boundary in Iran. But why? Well, look at the earthquakes back over in China, going all the way up into Afghanistan, north of Afghanistan in the tip of our arrow. 2 days back, there was next to nothing in Afghanistan or in Iran. That's when I issued the warnings for Afghanistan and Iran. And it was supposed to be coming up from the south, which it did. The pinkish earthquakes are from a few days ago. The whitish earthquakes are from today. So energy came up from the south and went right up the number 7 shaped bend of the Carlsberg Ridge. As we were expecting, it went 2 ways. One through the Gulf of Aden, up into the Red Sea. The other up the number 7 shaped bend of the Carlsberg Ridge and into Iran. And that is the path that the earthquakes took. The only thing missing that you don't see here is the earthquake in the Red Sea, which the USGS deliberately ignored. But you can go look it up on the EMSC side if you really want to find it, from a couple days ago, or a day and a half ago. Let me show you the plate boundary in Iran. It's going to make a lot more sense in like 2 seconds here. Plate boundary in Iran, the red line that goes down to the number 7 shaped bend that connects down to Gulf of Aden. That connects back down to where our 5.0 earthquakes, and connects back to the arrow that goes back over to here that just had its 50,000 foot eye blast. Now additionally, energy goes up across Myanmar, around and makes a bend through Nepal, and then goes up to the tip of the arrow in the tip of Afghanistan. And that's exactly what happened with the earthquakes over the past several days. Went right up around the bend of the plate. Again, look at the USGS map here. The bend of the plate here, and it goes up and back into Afghanistan and Pakistan. Back down to the south, then back over to the west, over into Europe. That is the path the earthquakes took, and they're all about the same size again. There's our 5, as we were expecting 4.9. Now, Syria got struck a couple days ago, and that's pretty interesting, 4.1. And a 4.6 up to the north, up in Turkey. But look at the rest of this. Look at the arrows. And we'll go back to the plate boundary map. Look where the earthquake struck in Turkey, between where both plate boundaries come together. The other earthquake, the 4, striking over here in Syria. The other 4 striking down in the Red Sea, the other 4 striking the Gulf of Aden, the other 4 striking up here in Iran. They're all coming back up here, flowing in that direction, and that's which way our arrows point overall, letting us know which way the flow is going. So, we have a warning going where these rings all overlap, east of Crete. And the warning could go up into that 5-ish range, maybe even 6. 6-ish might be possible when you combine this all together. But I certainly am expecting 5-ish. And that's again east of Crete. We're swarming back in the Aegean Sea, and we have a few small earthquakes going into the area just east-southeast of Italy and Albania and down near Sicily. Now, I have to talk about this. En France, a tremblement de terre. There it is, 3.5 and a 3.0 coming in on the coast of France. One right in the English Channel, or at the mouth of, south of the UK. It might not be called the English Channel there. What is it called? The French Channel? It's a little joke. But no, 2 3s coming in on the edge of the plate, and a new 3.7. Oh, take this 3.5, plus this 3.0. We get 3.6. Add in the 2s, you might get 3.6 and a half. Why does that matter? Because a 3.7, about the same size, struck out at the tip of the arrow in Iceland. So it's flowing out of Europe, but It's pretty obvious it's flowing out and around to the west and to the northwest. And to the east and north, we're not getting much. So Italy, over on the east edge of the Craton, it's not flowing up there yet. And notice the USGS map has nothing on it when it comes to this. They have the red lines, which show you the plate boundaries. Look where the plate boundary in Italy goes. Goes and dead ends up into North Italy at the Swiss Alps. That's what's pushing them up, by the way. The uplift is coming off the plate boundary. But the flow is going across Africa for the most part right now and ending up out over here in Western, Central, and South Europe, where the flow around the outside edge to the east really hasn't taken place much yet. And I say yet because there was a big earthquake down here. 7-point-something tsunami a few weeks ago. The USGS ignored that tsunami. You guys know that? A tsunami hit a couple weeks ago in Europe, and the USGS did not have it on the tsunami feed. I was bringing that info to you live. It was a disgrace. Really, I mean, I don't know what's going on there. And then, right at the same time that they ignored the tsunami, they brought the director of the USGS is being asked to step down for some kind of impropriety at the USGS. I don't know what's going on there. I really don't. The guy was apparently a good guy, the director. So, maybe it's internal politics. You know what I mean? Maybe the guy is great, but there's something else going on at the US. Other people. That might be what it is. But anyway, let's go across up into the North Pacific, where we go up into Alaska. That's where our most recent reported earthquake is. Let's see. 1942, 10 minutes ago, this 3.1 struck up here at the east side of Alaska, where it goes on into Canada. But in the last 2 days, it's a spread of 4s, just like the rest of the plate. Spread of 4s, and look at the size. Another 4.9. How many? How many, class? How many 4.9s are too many 4.9s before you start to think something's a little fishy? I gotta ask. Asking for a friend. Okay, so 4.9 right in the middle of the Aleutian Island chain. Why does that matter? We talked about watching the middle of the Aleutian Island chain for 5.0 range. And now a 4.9 comes in. A stepping stone path of the same sized earthquakes spreads out from that all in the 3 range. 3.1, 3.0, 3.1, 3.0. Going right up to the edge of Canada and Alaska's border. But look at the jumbled mess going across the middle of the plate boundary. That goes right along the coast. But then up into the edge of the Craton. And you see that we actually have a spread going across Anchorage, right up to Mount Denali. Once we get past Mount Denali, then it spreads up to the Selawik Hills, or next to it. I do want to show you what's up here. Shungnak, Alaska. But there's something interesting at this location. Again, something that's worth looking at. There's earthquake striking next to this, so we have to make note of it. When I looked in on this before, and I saw this round shape here, and it was covered in white, well, I just thought it was a glacier or something, and at first I didn't even pay attention to it. But then a series of more earthquakes started to strike around it, and I zoomed in on it, and I noticed that it had a ripple-like shape coming out from it where there's no snow cover. So something's going on here, and I had to look up info on it to find out that it's actually silicate sand deposits that get covered in snow and ice. But overall, and they stay frozen longer. I guess the water maybe penetrates into there. But you can see it there. It's a sand deposit. These are being pushed up out of the plate, and they actually go right down to the river down here, apparently. That's what makes all these cool ripples in the river. Huge deposits of sediment coming out from there. But anyway, so the plate is grinding here, and where it's grinding, maybe there's a greater deposit of silicates, but this is like, I would think of this more like White Sands Alamogordo down in New Mexico, on the edge of the Craton down in New Mexico. Look at the Craton edge going down into the United States. See how it goes down through Colorado and then down through Texas? What state is between Colorado and Texas? New Mexico. And that's where the edge of the Craton goes, and right in the middle of the edge of the Craton is where the silicate sand deposits are down at White Sands. Now, I don't know if these are white sands. These might be gray sands or magnetite sands. Nonetheless, that's what that is. Now, over to the west, we have the Selawik Hills, old volcanic complex from the Pleistocene, from the Ice Age. That's where our earthquakes go, up to the silicate sand deposits. Now, over to the east, we're strictly on the interior portion of the craton, and we're bleeding over into Canada right there. So we're actually getting some Canadian quakes reported. For instance, a 3.2 in Yukon. Is that the Yukon? Hold on. They have it listed as Alaska, British Columbia. British Columbia. It's right at the border with BC and Yukon. It's like a matter of, let's get the mileage on this. It's like a matter of 5, 10, 25 miles or so to the border of Yukon. But it's in Canada, and it's a 3.2. Well, a new 3.1 just struck on the other side of the border right along the coast, just within the past 15 minutes. So wouldn't you say 3.1 and 3.2, they're about the same size, aren't they? Now, what happens if you take a 3.2 plus a 3.1? It equals 3.31. Why does that matter? Because there's a 3.4 right behind it that just struck a few hours ago. So, in other words, it's the same energy going down along the coast. It's within a hair of a point of one another. Now, this brings me into the Pacific Northwest of the United States of America. And before we get into the shenanigans that's going on up here in the PNW, Pacific Northwest, I want to draw your attention to this 3.5, again, about the same size as what's up here, coming in right down here at the coast of Eureka, California. And the Europeans are reporting it at 3.5. Hold on, before I say it's a 3.5, let's go pull the info from the good old USGS. USGS. From the USGS. Petrolia, California. And I'd like to turn on the tectonic plates in U.S. faults. Do you see the thick red line here? This is the Juan de Fuca fracture zone. And the new 3.5 is coming in right on the south tip of it, is it not? Now we skip over all of it. And we get up here, and right where the plate boundary is coming in across Alaska. Remember what I said about being up here next to the Yukon border? So somewhere right up here where BC meets Yukon, we have our other 3.5 worth of energy, basically. 3.7. So on both sides of the Juan de Fuca, we got the same sized earthquake activity. But hold on, because in the middle of this, there's no... All of a sudden, in the last 24 hours... Here, let's just make sure about this. Let's turn on to 0.0. All right. So I did an update last night, and I showed you the earthquake in Crater Lake. Let's turn on our last 24 hours worth of earthquake, shall we? Last 24 hours. So I told you there's some shenanigans going on up here, right? Now just wait. So we have one earthquake reported across the whole region. We have the same size coming in, and we have the same size coming out of the region. But the region in between, jack squat. We have to go over to the University of Montana where they start reporting, University of Wyoming, to get any reported earthquakes. So the people who are responsible for reporting the earthquakes up here, you got to ask what's going on. Let's go look at those 0.3, see what it is. Ashford, Washington. This is from 7:56 UTC. What time is it now? This is from like 13 hours ago. This one microquake. So in the last day, it's like somebody hit an off switch in the Pacific Northwest when it comes to reporting earthquakes. And the last earthquake that came in is on the side of Mount Rainier, a slightly different side than I showed you yesterday. We were on the northwest side yesterday. Now here today, in the last 12 hours, we're on the southwest side. Something's going on around Mount Rainier, obviously, and I told you yesterday in my update. When the center of the volcano rises, then the outside edge moves a couple days later. That's what's going on with that volcano. But then, hush, hush, off. And let me say, we should probably go check the tremor map to see if there's any tremors going on up here in the Pacific Northwest. Let's go take a look together. Let me hold your hand. Grab my hand, everyone. Let's go look. What's going on? Bum, bum, ba-dum. Sound the Price is Right losing horn. Something went wrong. Please try again or send us an email. They're asking you to send them an email. Oh, no, that's just a recipe for disaster. Never ask people to send them an email. Maybe make a little form to fill out if there's something wrong. But something is wrong. Let's go back to yesterday. The day before, the 27th, 2 days ago. Well, look, there's 43 tremors that are reported. Now, hold on. Didn't they tell us a week ago or so that the slow slip stopped, that the plate slow slipping stopped, and that the little red dots wouldn't be there, and that they were just going to, it was going to stop? And it didn't stop. Instead, on the 27th, 40-something tremors and an explosion. And a hotspot. Explosion, hotspot, tremors, all in the same region a day and a half ago when I did my update. Then yesterday, Saturday, all of a sudden, this happens. Now, as that happens, and we're not getting any tremors reported out of the Pacific Northwest, all of a sudden the earthquakes stop. Gee, Mother Nature must just be cutting us a break. No tremors, no quakes. Last quake reported technically was last night UTC time. And then we go over to the east, and all of a sudden there are some earthquakes. And they're happening above the magma chamber from Yellowstone. Yellowstone at the surface over here at Wyoming. But the magma chamber goes down below central Idaho. Also, we're on the edge of the Craton coming out of Montana. So I just am curious about this, about the outage that we're having here in the Pacific Northwest. And the timing of the outage is just a little bit strange, especially when the rest of the plate goes into massive overdrive and the whole West Coast gets put into lockdown, second lockdown, where everybody's inside and you would need to know if something big was happening. Now, something else happened here. To top it all off, something else weird happened here in the past 2 days. The satellite that we use to view the hotspots suddenly had a technical outage of its own, and it put a white bar, censorship bar, I call it, but they wouldn't call it a censorship bar. An outage happened where the whole west coast of the United States was white and blanked out for several hours over these 3 states: Washington, Oregon, and California only. Then you back it out and look at Canada, no whiteout. Back it out and look at the whole region, no whiteout. Just the close-up view that you would use to go look at the hotspots. That was what was whited out. You could look at the continental view. You could look at the whole west coast. But then you go look in the GOES West satellite view and white out it is. It must be another equinox, I guess. An unheard of equinox, because that's what they blamed last time. They tried to say it was an equinox happening and the sun was causing a problem. Well, we have a solar flare that's hitting. Or not solar flare. A coronal hole stream of strong solar wind. Charged particles hitting the Earth. Now, we also have had an M-class flare in the last day on the opposite side of the sun, or non-Earth facing. But still those have an effect, especially M and X class. So once it gets into M as in Michael, like my name, M as in Michael, but seriously, once you get to those levels, that's when you start to see an Earth effect, major Earth effect, big increase in seismic activity. It's not just the coronal holes in the wind, it's charged particles coming to Earth, whether it's from a CME, a coronal mass ejection, whether it's from an Earth-facing solar flare, or a solar flare that can happen on the opposite side of the sun. They've now found that those too have an effect, magnetically speaking, coming around the sun, and the spiral, if you will, that all the planets are doing behind the sun, that spiral, one of the arms or multiple arms, can become perturbed. And when it comes back around and hits the Earth, we get an effect, a reverberation. So looking at 24 hours worth of earthquakes, we don't have any to report to you in the Northwest. One from yesterday, last night, on the side of Mount Rainier. Yellowstone's moving, but not that much, and the tremors are out. And that's outage as in the site is out. Getting down to Northern California, where apparently they're managing to still somehow report earthquakes. You know, this is the 21st century, so of course we're not going to have earthquake reporting. What am I thinking? Let's go up here to French Gulch. You know, this is the dark ages of the internet. With an inquisition and everything. The question is are you pious or not? Don't worry. The online community will decide for you in a mob rule, just like it's the Dark Ages. So where are we? Speaking of the Dark Ages, well, we've got Electrical lines coming through here. Big ones. Big high voltage tower power lines. Not the kind that go to your house. The kind that come from an electrical generation station at a hydroelectric dam like this. So we have a giant hydroelectric dam on the lake here. Is this Papoose Lake? But huge dam, electrical generation, and coming out from it, high voltage power lines. Right next to it, an earthquake. Redding, California, earthquake. Now wait a second, that's up here on the north side. That's where our tremors happened a couple days back. Let me take you in and show you, since some people don't know about the tremors. Again, it's off today. All of a sudden, whoops, whoopsie. But let's go back a few days. Go down into California. Let's go back to well, first of all, let me minus this out so I can get it all on the same screen. Let's go back to the 21st. See, we're in Northern California. Let's go back to the 20th. See how we're in Northern California again? Let's go forward a couple days. Let's go to 23rd. Southwest Oregon, 24th. Northern California, Southwest Oregon, and Northern Oregon. Then 25th, 0. 26th, look where we are on the 26th. Do you see it? Let me zoom in on it. We're at Redding, where it shifted. But what shifted? The plate boundary. Let me show it to you on the USGS map here. Here's the plate boundary as it comes in to Northern California. And Redding is right in here on the southern arm of the Juan de Fuca. So we tremored and shifted there. Now we have an earthquake there. Didn't we just have a hotspot there a couple days ago? Sure did. So then we have an equal spacing of quakes going down all the way to the Bay Area and beyond, down the creeping section of the San Andreas, but then we stop down here and jump over into the valley. So what's up here where the big stack is? And the equal spacing of quakes, 3.5, 1.9, 1.5, stack of quakes. Cobb, California. Cobb, wait. This should be the geysers. There it is. Depending on which earthquake you click on, it'll give you a different name. One tells you what's there. The other keeps you in total ignorance. Cobb, you'd have no idea. Geysers, you get a clue. But it's not just geysers there. There are geothermal turbines and all these pipelines. And the pipelines go to drill points where they've drilled in and they inject water. The water gets steamed off, taken up to the turbines. The turbines are turned, I don't know if that's the turbine set or if it's right next to it, generating electricity. And all of these turbines and steam pipes go out to more drill points. And this is on the edge of Clear Lake Volcanic Field. Clear Lake. Big volcanic field, lots of heat down below from the magma chamber, and all of this resides on the edge of the plate boundary, the thick red line. So that's where we start. Again, we go down this red line of equal spaced earthquakes, and we go into the geysers. But then we get down to the Bay Area, and we have the same thing going on. Look at the size of the quakes. 1.7, 1.7, and a 1.7. Bay Area going down to the south. Down to this 1.5 and 2.0. Now, wait a second. If we take the 1.7 plus the 1.7, that's 1.87. We can round it up to a 1.9. Then we add in the other 1.7, and we're right at about 2.0. Add in the other one, and we're at 2.01. I mean, we're at a 2 cumulative energy around the whole Bay Area. Again, 3 of the same-sized earthquakes, please. All on the San Andreas or Hayward Fault. But once we get down to this 1.5, let's get the coordinates here. Pinnacles, California. We jump off and go over into the valley. I've told everybody this happens so many times previously. So I tell everybody, energy comes down the creeping section of the San Andreas, gets down to Pinnacles or Park Field, and jumps off the tracks of the San Andreas like a train being derailed. And there's even a spot where you can see it kind of goes off to the side here. Now look where it goes off to. Here is the San Andreas going down to the south. It's a diagonal line in the mountains. But branching off of it, you see this. And it goes right over to these. What are those? What are those? Those are oil and gas wells, Mr. Paul. Ah, yes, there you are. Flare, burn apparatus, and we're all around here with a bunch of oil and gas pumping. So we break off the San Andreas, and we go over to the frac wells. Now let's pull the 2.0 then. New Idria, California. I hope you're learning something. If you're new, you're going to learn that the volcanoes are getting hit and that the pumping operations are getting hit. And here's where the 2 is. It's on the other side of the frac ops. I always look 6 to 10 miles because they can drill out by several miles at an angle from one of these drill points. So let's just go see how far we are from the frac wells. We are 7 miles to the actual 7.7 down to the actual well. Now they can drill out by many kilometers or miles at an angle or sideways. Meaning they could drill in here and drill over down below this spot. Now I don't know if they'd go below the county line, but I think that's somewhat irrelevant. There's probably more over here to the east-southeast. Well, I know there are. Starting right here. There's thousands of them. Oil and gas wells. This is where we start in earnest. Look at the pipelines through here. And the pipelines connect to our oil wells. So this is oil, and we go down across huge pumping operation where every one of these pads is a different oil well. All right, so you get the picture. We're on the north side of a huge oil pumping operation. We're right next to some frac wells, which themselves are on the north side of the pumping operation. And that's where the earthquakes jump over into the valley. It's not a coincidence. I've told you this happens so many times. Force is exerted down the red line. Wait, let me get that back on here. Force is exerted, or power, tension, goes down the San Andreas. And you get down to here, and all of a sudden you've drilled the heck out of it right next to the San Andreas. Well, the force goes into the perforation point. And the perforation point is huge. It aids in the flow going down across the valley, and we should see some new earthquake activity break off down here at the south tip of the valley. Since energy has been deposited into the plate, look at it this way, a diagonal line of quakes. 3.5 up at the tip, going down across the volcano, causing an excitement at the volcano and the drill points. An excitement on the Hayward and San Andreas, all 1.7. And then the cumulative total goes down and jumps off the tracks, like a train coming down a track and jumping off over into something when it's been derailed. Now it's going to flow down to the south tip of the valley, and we should see something similar in size break off down here to the south, or bigger. Now, connecting point between the two, by the way, look down to the south. Do you see all these? So we looked a few of these up last night when they struck, when I did my update last night. Let's go pull the 2.2 up here in East Los Angeles. This should take us down right into East LA. I love doing this, looking up the earthquakes that I don't normally know what's there. Sometimes you find stuff, other times you don't. I don't know if we looked this up last night. Man, I had a long day yesterday, guys. Oh, no, okay. We did look this up last night. And I brought up these right over here to the east. The oil pumping operation here. And this is a big one. And you can see the shadow of the jack of the pump there. That's just one of a bunch across that hillside, going across up to the golf course, back down to the east by southeast. So we're just a hop, skip, and a jump from the actual current pumping operations. There might be more up here on the north side. There could be. I don't know. I don't have them all marked, that's for sure. There could even be some down here inside of these urban areas. But let's just measure. Let's measure from the earthquake epicenter over to the pumping ops. Whoops. And this is just a rough measure. I just need to know. 6.5 miles. What did I tell you we watch? 6 to 10 miles. Because they can drill at an angle down below an area, and there could also be older oil wells somewhere right around here that I just don't have marked. Like sometimes they're even set out right on the sides of the roads here. Like not even protected. Sometimes they'll have a fence around it or something. Sometimes it'll be at a park even. On the edge of a park. I don't see anything here, but that doesn't mean anything. Trying to find anything in here is going to be pretty hard. What do we got going on in there? Look at that. Okay. That's like a tent city built on the side of the highway, guys. All right. Let's go down to the east-southeast. Villa Park, California. And paste the coordinates in. At least it's nice and warm in California, guys. I see that, and I feel for the people who are living in an area that's extremely expensive and that they have to do that. All right, where are we? Well, yeah, I mean, well, we're right next to the NEXRAD radar, the high-powered microwave transmitter, 750,000 peak watts beamed out of there. How do they get 750,000 watts? You probably are asking yourself. They take a small amount of electricity, small, like enough to power a few appliances in your house, maybe not even. And then they microwave that up, basically, in a klystron tube. A klystron, it's this device that will amp up your power from a little bit of wattage to megawattage in a klystron. Now they'll use like 1 klystron to power this NEXRAD radar. So it'll take the energy and beam it up to 750,000 watts. Now, you know where else they use klystrons? Let me show you. Klystron, CERN. How about that? Hey, CERN's klystrons. Let's go get an image of it. Do they have an image of CERN's klystron banks? Maybe. Yeah, here we are. Wait, no, that's not it. But this is at a linear accelerator, so this is going to be the same thing that we see in CERN. Ah, here's CERN. Here it is. Here's CERN. This is a picture from CERN directly. Now, do you see each one of these? Each one of these is like one of those klystrons that powers the 750,000 watt NEXRAD radar. One of these. So they'll use this to amp up the power. They'll take a little bit of power at CERN, a few 100,000 watts maybe, and then zap it up again, zap it up again, zap it up again, and this goes on and on and on and on and on and on. They have to ride a scooter, an electric scooter. They ride along through here. How ironic, it's electric, right? An electric scooter, they ride along the bank of klystrons. This is just to power one of the beams at CERN. So that's how they get their picowatts or whatever they are. It's like the most insane amount of power ever. They're just literally zapping up the energy in all the klystrons. So 1 klystron is enough to power the NEXRAD radar around a several 100-mile area. And so the banks of those at CERN. Anyway, we're right at the foot of that. And, well, you got a small earthquake right next to the foot of that. Is it an earthquake? Is it an explosion of some kind? I don't think it is. Okay. So the rest of these earthquakes now. Going in a diagonal line down across the area, west of Salton Sea and south of Salton Sea. And we dead end down at the California-Nevada border again. And I say again because this is just such a regular occurrence. We'll show you the line of quakes that comes across from where that NEXRAD is that I just showed you. And it goes down, the quakes go down west of Salton Sea following the San Jacinto Fault. And dead end at the border with Mexico. Well, down at the border, where it dead ends, starting at Salton Buttes volcanoes, which is a set of volcanoes, by the way. An old buttes, and on the side of here, they've drilled in to get steam. And there's a whole bunch of these geothermal turbines. And they go down to the border, right down here, where there's more geothermal turbines and a solar farm. But the geothermal turbines go out the pipelines. Then the Mexicans are doing their version of it on Cerro Prieto volcano here, with its awesome graffiti on the inside. Look at that. That's awesome. Okay. So over here on this side, though, geothermal as well. Look at all those. Geothermal turbines, pipelines, electrical generation. So that line of quakes goes down west of Salton Sea, and it goes down. There's one earthquake on the east side of Salton Sea. That's up by the military base, where the hotspots were. But the rest are on the west side, and it's all flowing. The only spot that needs to be filled in down here is the south tip of the valley, which goes over to Ridgecrest, and I haven't talked about the earthquakes over at the California-Nevada border, but they can be summed up easily as being put as volcanic. All of the earthquakes that you see here, these 3 stacks, are all directly next to noteworthy sized volcanoes. Even the earthquakes in between, this one. There's one lone earthquake out over to the east.
Nuclear test site.
So which should I show you first? Let's start up here with this cluster up to the northwest at Tom's Place. This is east of Mammoth Mountain Volcano, ski resort / volcano. I think of the movie Dante's Peak, starring Pierce Brosnan, where they have the mountain town. It's beautiful, but it's on the edge of something that's a little troubling. Here's Mammoth Mountain. This is Long Valley Caldera supervolcano, with 1,000 cubic kilometers of melt measured down below, classifying it as a supervolcano. Now, in the middle of this, they drilled into it to get steam. Pipelines again, turbines, etc., etc. The king of Siam I am. And now over to the east, the Grand Poobah of Dutchistan, I mean. Yeah, guys, you got to have fun with it. Let's go over here. Again, we're jumping across California's border. And we're going over to Monte Cristo Hills Volcanic Buttes. Right there, volcanic center. And this broke apart almost 6 months ago. Broke apart with a 6.5 earthquake and a 12-mile-long surface fissure fracture formed across through here. And the earthquakes have matched that ever since. Every day. And they spread over to the supervolcano, pointing in the direction of it. So a swarm of earthquakes inside of the supervolcano, a swarm of earthquakes over to the east at Monte Cristo Hills. Now, the third swarm of earthquakes is another diagonal line going northwest to southeast. How many is that? A diagonal line going northwest to southeast across California's coast. A diagonal line down across Southern California going northwest to southeast. And look, a small microcosm of it, another diagonal line of earthquakes going northwest to southeast. That's at Ridgecrest. We start here at a place called Coso Volcanic Field. And we dead end it down into the lava mountains. Let me show you. Starting right here. Coso Volcanic Field. Pause and read it if you need to. The earthquakes begin just on the north side of this. These are rising domes, pushed up by magma from down below. Devil's Kitchen is a geothermal pumping operation. Sound familiar? A drill point where they're generating electricity. So there's something up with the electricity, the earthquakes, and the volcanoes, and the drill points. There's a connection. Now we go from there, where the electrical generation is started, at Coso Field, and we go down to the east-southeast. We dead end into the lava mountains. So let's do that. East-southeast from there, lava mountains down here. So what's in between them? Well, look what's in between them. Another volcanic field. The Volcano Peak Volcanic Field that goes down into China Lake. And look at all the eruptive cones here. 1, 2, 3, 4, at least 4 spatter cones there. 5, 6, 7. Smaller's over on the side, 8, 9. 10, 11, 12, 13, 14. And a rising dome here, 15. Certainly another one on the north side, 16. And more over here. More that fissured and fractured and broke apart. Amazing, right? The earthquakes go in a diagonal line on the east side of there. So recapping one more time. Diagonal lines of quakes showing that energy is transferring in across California's coast, going down as far as Pinnacles or along the San Andreas at least, and then jumping over into the valley. Same time it's jumping over into the valley here, it picks back up over at the supervolcano and the fracture point to the east, Monte Cristo Hills Volcanic Buttes, goes down to Ridgecrest, Coso Volcanic Junction. Now, in between the two, we have these smaller earthquakes, Ryan craters and Ubehebe craters. Let's go pull the 1.5. Furnace Creek, California. Gets its name from the heat in the valley. It's like a Death Valley scenario there. Furnace Creek. I think that's where it gets its name. I think that's something to do with the shape of the rocks there, too. Okay, there we are. Now look where we are. Ubehebe craters, Ryan craters, right in between the two. Yesterday we were at Ryan craters. Today, again, we're right on the outside edge of Ubehebe craters. And this is a giant in-the-ground crater. Look at that. Massive. Ubehebe craters there, that's where the earthquake is, right next to it. The 1.1, same thing. Now that's actually right next to Ubehebe, the 1.1. So while the 1.5 is right in between them, the 1.1 is right at them. Over to the east, like I said, nuclear test site. 0.0 kilometer depth. A surface earthquake, but it's small. They're not doing any kind of nuke test there now. Let me show you what's here. Okay, now you should be able to see it. Do you see all of these? These are underground nuclear test sites, craters. And we can turn on the Google Earth community to get info on the nearest crater, I think. U.S. nuke Operation Pahara. 20 kilotons on December 12th, 1973. That's at least the nearest that I can see. What's this one? Oh, wait, no. U.S. nuke Operation Rosset. March 5th, 1968. Undisclosed kilotons. That's even closer. Maybe there's some even closer. What's this? I have no idea what we're looking at there. Don't want to speculate. What are these? Oh, wait. Somebody just said, what are these and this? I didn't know that. Ha, I just moved my mind. That's all construction equipment. Amazing. Okay. Wonderful. We're at the crater from 1968. Is there anything else I need to talk about? Texas. Oklahoma. 3.3 earthquake on the edge of the craton in Texas. Look at Texas on the craton diagram. I mean, it's pretty obvious. The edge of the craton makes a bend down through Texas. Look at where the earthquake is. It's right on the arrow where the bend is marked. So grabbing the coordinates at Coyanosa, Texas, we will put them in. It's a 3.3 magnitude at 3.7 kilometer deep. Well, when you see what's here, I think you'll understand why earthquakes are striking on the edge of the craton in Texas. Here's the epicenter, and look where we are. We're right on the edge of another oil pumping operation. Might have some gas going on there too, but it looks like we have wastewater disposal, fracking, oil extraction, and oil pumping going on here. All of it. Every one of these different pads here, different oil, gas, or wastewater disposal location. They will dispose of the wastewater to break apart the shale to release the oil and gas and then drill in to get the oil and gas. Here's a team of people out here with a derrick. They're using the mud slurry. Wow. They'll inject that. Now, going over to the east, look at how many different drill points there are. You get the picture. So many. And when you get that many drill points on the edge of the craton, you exert 3.0 energy into the plate. 3.0 energy travels across the plate. Pretty darn basic. And it's about the same size that came in on the West Coast. Once we get over to Oklahoma, that's where we pretty much stop at this point with mid-range 2s. Pawnee, Oklahoma. Let's put the coordinates in at Pawnee and just show all the new viewers what's in good old Oklahoma. Getting close to home here. I'm up in Missouri. Hey, wait, we've got hotspots down there. Hold on. Okay, what's this? Hey, look. A tank, a pump, and a jack, but it's barely even noticeable. That's the old well there from previous. Now, look on the road, and you'll have 3 more tanks, another set of pipelines, and a flare apparatus, safety for burning. Here is the shadow of the jack of the pump for creating that pressure. Now, here's an even younger pad. This is newer. They now require from state law a pad certain size, has to be far enough away from certain places and easily identifiable from air, and a berm for protection built around it in case of a spill. And that's where we are. Oh, wait. We're right where the 5.6 earthquake struck, the biggest in state history, on September 3rd, 2016. You know what? Maybe I can go pull the info from my YouTube page. Oklahoma 5.6. Wait. Guys. I'm searching on my channel. I'm searching on my channel and look what they're doing. Dude. I'm searching on my channel for my videos. This is on my channel search. This is not a YouTube. I'm not searching up top. I'm searching on my channel for my own videos. And look what they're doing. They're populating Mr. BBB 333, CBS News, RT America. Then they put my video in here mixed in with BBC. Are you freaking kidding me, man? What the? Dude, that's it, man. I'm going to sue these people. I'm going to sue CBS. Man, this is my business. You don't have a right to come into my business. You scumbag KOCAO News, CBS News, BBB 333. You guys owe me money. My God, what a scam this is. I am so sick of getting messed with, man. Just trying to find a video I made on my own freaking channel. And BBB 333 comes up? Please, man. Let's go see if it does it on his channel. Oh, man, I get angry. Sorry, guys. I'm angry. Let's go see if it does it to him. Some new rule? Let's just search earthquake. Well, hey, look. All his videos come up. No CBS News. Nobody else's shit coming up in his feed. Just him, like you're supposed to get. What the God damn it, man, I'm pissed. All right. I'm tired of getting messed with and shut down. I want to find my own video on my own channel. How do I do that now? What I got to do? Scroll back 8 years and 5 years and find it? Here, let's do that. Let's see if we can even scroll back that far. Oh my God, I'm going to do it. I'm going to scroll back 6 years, 2016. My God, 4 years. 4 years I'll scroll back. Let's do it. Oh my God, you know how long this is going to take? My 4.9 jersey. You know, somebody sent me a jersey, a St. Louis Blues jersey. It says 4.9 on the sleeves and everything. I wore it to the Blues game. It's hilarious. No way. We cut off a year ago. They cut me off a year ago. You can't scroll back past a year. Grant Thompson, the last video that you can come in on. Look, I'm scrolling down. You can't scroll anymore. They won't even let you go back but a year. They cut me off but a year. You can't even scroll back a year on my freaking channel. What the I'm sorry. I'm getting angry. I'm getting so angry. Oh my God. This is a tragedy. You can't scroll back but a year. I'm going to hit refresh. These are my videos. I should be able to scroll back through my own videos, guys. I can't search my own channel for it. It puts CBS News and BBB 333 up on my freaking channel, on my search. And then we scroll back and look, I'm scrolling down. Look, it stops at Grant Thompson. And I clicked on all videos a year ago. More than a year ago. Goes back a year and a half. And then just stops. Oklahoma. 5.6. There it is. I mean, again, this is CBS This Morning, KOCO News, Mr. BBB 333, even the fucking Russians, man. Oh, I just dropped the F-bomb. Uh-oh. Niet. Niet. Suka Bieliat. Niet. Mikhail Yanich, special agent, not allowed to report for duty. Oh, can't believe I just dropped the F-bomb. I'm sorry, guys. I'm done.